Have you ever stopped to think about how a shiny new bike can turn into a pile of rust? Or, how a tiny seed grows into a giant tree, creating the very air that we breathe? Well, it all boils down to this incredible process, the chemical reaction. It's like the universe's ultimate remix, and we're about to break it down.
So, yeah, what could rusting iron and the oxygen we're breathing in right now possibly have in common? I know, they seem like complete opposites, but the answer is that they're both the result of a chemical reaction. It's this fundamental process that's happening literally everywhere, all the time, all around us, and even inside of us.
So what's really going on here? What does it actually mean for something to react? Let's get into the science of this amazing transformation.
Okay, at its very core, a chemical reaction is all about breaking and making bonds. You start out with your ingredients, right? We call those the reactants. The reaction comes along, snaps their chemical bonds, shuffles all the atoms around, and then forms brand new bonds. And what you get at the end are totally new substances, which we call the products.
A really good way to picture this is to think of it like a dance. All the atoms are the dancers on the floor. During a reaction, none of the dancers vanish. They just switch partners. They rearrange themselves into new dance groups. The number of dancers on that floor is exactly the same at the beginning of the song as it is at the end.
And that idea, that nothing ever really disappears, that's not just a cool thought. It's actually one of the most important, unbreakable rules in all of science. It's called the law of conservation of mass.
This rule was figured out by a brilliant chemist named Antoine Lavoisier. And what he said was, in any reaction, the total weight, the mass of all the stuff you start with, your reactants, has to be exactly equal to the total mass of the stuff you end up with, the products.
So here's the bottom line. You can't create matter out of thin air, and you can't make it disappear. It just changes its form. You can't magically gain atoms, you can't magically lose them. The universe keeps perfect records.
All right, now this is a really, really important point, because this is where people can get a little tripped up. We see change happening all around us, but not every change is a chemical reaction. We've got to know the difference between a chemical change and a physical one.
And this explains it perfectly. So look at the left side, a physical change. You take an ice cube and it melts into water. It changed its state, but chemically, it's still H2O. Now look at the right. That's a chemical change. Iron atoms mix with oxygen atoms to make something brand new, iron oxide, which we all know as rust. And rust has totally different properties than shiny iron, right? It's a whole new substance.
Okay, theory is great, but let's see how all of this stuff, the reactants, the products, that unbreakable rule of conservation, comes together in one of the most vital chemical reactions on our entire planet.
Yep, we're talking about photosynthesis. Now, don't let the equations scare you. It's pretty simple. On the left side, you've got the reactants, 6 molecules of water and 6 of carbon dioxide. Then the plant does its thing with some sunlight and boom, on the right side, you get the products, 1 molecule of glucose, which is basically plant food, and 6 molecules of the oxygen we need to live.
And this is where you can actually see Lavoisier's law in action. It's amazing. Let's do the accounting. Before the reaction, in the reactants, how many carbon atoms? 6. And after, in the products? 6. It's a perfect match. Okay, what about hydrogen? We start with 12, we end with 12. Check. And finally, oxygen, we start with 18 atoms, and we end with 18. It's a perfect balance. Not a single atom was lost or gained. They were just remixed.
So that was a lot, I know. Let's just quickly recap the big ideas, the main takeaways from all this.
First off, a chemical reaction is all about rearranging atoms to make completely new stuff. Second, remember that golden rule from Lavoisier: matter is always, always conserved. You end with what you started with. Third, don't forget that a physical change, like ice melting, is just a change of state, not a new substance. And finally, the whole point of a reaction is that the products you get are totally different from the reactants you started with. When you start to think about it, chemistry is happening everywhere. It's in the food you're digesting right now. It's in the battery that's powering the device you're watching this on. It's everywhere. So I'll just leave you with this question to think about. What other invisible chemical reactions are happening all around you, right at this very moment?